Welcome to solverfy.
Hey there. In this problem, we are given the formula C5H11F. And we are asked to give an example of structural isomers as well as an example of optical isomers. So let's start with structural. Structural refers to two compounds that have exactly the same formula but a different structure. So there are quite a few different ones you could draw for these. I'm just going to draw a pair of isomers here. For one of the molecules, I am going to draw it like that, where each empty dash there represents a hydrogen, so that would be 11 hydrogens. For its structural isomer, I am going to draw and put 5 carbons in a row again. I'm going to put the fluorine on carbon number 3, and then filling in all of the empty spots with those 11 hydrogens. So again, there is a hydrogen attached to each empty bond I have here. These are two structural isomers. They have the same formula, but they're going to behave differently because they are different compounds due to their different structures. So these would be structural isomers, since their structures differ, yet they have the same formula. C5H11F. Let's move on to optical isomers. Optical isomers have to have an asymmetric or a chiral carbon. What that means, let me change back to black here. What that means is we need to have a carbon. Hold on just a second, let me get this sketched and then I'll talk about it. We need to have a carbon that has 4 different things coming off of it. So I have drawn such a carbon here. We have the carbon I'm talking about. I'm going to go ahead and go over it in red. That carbon has 4 different substituents attached to it. It has a 3-chain carbon coming off one side, a 1-chain carbon, a hydrogen, and a fluorine. Its optical isomer would be a mirror image of it, but it would not be superimposed upon it. You cannot superimpose upon it. So I said it's going to be a mirror image. So let me draw its mirror image here. So these two compounds are mirror images of each other, but they cannot be stacked on top of each other. They cannot be superimposed because the carbon that I drew in red there is a chiral carbon. It has 4 different substituents coming off of it. This is what gives us optical isomers. This particular formula cannot have geometric isomers because in order to have geometric isomers, you must have a double bond. So since there is no double bond, we have no geometric isomers. The double bond serves to fix the atoms in place so they cannot rotate around the bond. And then that's what gives us our cis and trans geometric isomers. But we can't have those here because this formula will now not allow us for a double bond. All right, there you go. Thank you so much for watching.